A sample of liquid consists of carbon, hydrogen and oxygen. It is subjected to combustion analysis. 0.5439 of the compound gives 1.039 gram of carbon dioxide and 0.6369 gram of water. Let's determine the empirical formula of this compound, shall we? As always, we will begin by formulating our data. So, we have mass of compound is equal to 0.5439 gram. Mass of carbon dioxide is equal to 1.039 gram. Mass of water is equal to 0.6369 gram. According to the steps we discussed in the previous video. First, we need to calculate the percentage composition. This will be done by using the following formula. Mass of carbon dioxide divided by mass of organic compound multiplied by 12 divided by 44 multiplied by 100. By inserting the values in this formula, we will get 1.039 divided by 0.5439 multiplied by 12 divided by 44 multiplied by 100 is equal to 52.108% carbon. Now, the second step is to find the number of gram atoms. For that, we will use number of gram atoms equal percentage divided by atomic mass. On inserting the values, we get 52.108 divided by 12 is equal to 4.34 gram atoms. The third step is to calculate the atomic ratio, which is by dividing the number of gram atoms by the smallest number. For that, we need to calculate the percentage compositions and the number of gram atoms for hydrogen and oxygen too. For hydrogen, the percentage composition will be calculated in the same way as we did for carbon. Percentage composition equals mass of hydrogen divided by mass of compound multiplied by 2.016 divided by 18 multiplied by 100. This will give 13.11% hydrogen. Next, we will calculate the percentage composition of oxygen by using the difference method. Percentage of oxygen equals 100 minus percentage of carbon dioxide plus percentage of hydrogen. By putting the values, we get 100 minus 52.108 plus 13.11 is equal to 34.77% oxygen. Let us now calculate the number of gram atoms of hydrogen and oxygen. For hydrogen, number of gram atoms equal percentage divided by atomic mass. On inserting the values, we get 13.01 gram atoms. For oxygen, number of gram atoms equal percentage divided by atomic mass. On inserting the values, we get 34.77 divided by 16. This will give 2.17 gram atoms. Now, by looking at the values of gram atoms or moles of all the three elements, we see the smallest value is that of oxygen, that is 2.17, right? So, this will be used as the denominator for calculating the atomic ratio. We know atomic ratio equals the number of gram atoms divided by the smallest number of gram atoms. For carbon, 4.34 divided by 2.17 will give 2. For hydrogen, 13.01 divided by 2.17 will give 6. For oxygen, 2.17 divided by 2.17 will give 1. Can you see it? All these atomic ratios are obtained in whole numbers, which means we have found our empirical formula, that is C2H6O.